course, nothing really will beat the interaction, the engagement that we enjoy at COA meetings or at an intermodal exhibition. But the aim of these webinars is to enable us to come together as a community and consider issues of common interest, and over the months focus on some of the technical, market and operational issues that the industry is facing. So as you know, today's webinar is looking at container coatings or eco-friendly coatings, and particularly focusing on the issues that the industry is facing. COA membership and work program covers a wide range of technical and operational matters, and so future webinars are planned for work that we're doing on developing standard communication protocols for reefer machinery. We're looking at flexi tanks, we're looking at container repair and container flooring. And the work, the webinar today is to some extent based on the work that the COA Container Coatings Work Group did earlier this year, and they produced the report. And the picture on the left of your screen is the front cover of the report. I'm sure many of you have seen it, but it is available for members to download from the website. Before we start, and before I introduce today's panelists, please let me go through the rules of the webinar. And these are basic house rules. Firstly, as with all COA meetings, we ask all participants to comply with the COA antitrust guidelines for conferences, which basically means that there's no discussion about rates or prices or competitive matters. We ask everyone to keep their computer sound system on mute unless they're speaking. And this helps us to avoid background noise. We've got over 50 registered participants, and I can see about 32 read online so far. As I mentioned, our aim is for these webinars to be informative and informal. And during the course of the presentation, at the end, participants are welcome to make comments and ask questions. If you wish to speak, obviously unmute yourself and ask the question. Please introduce yourself. It's useful if you can use the hand icon at the bottom or the top of the screen. And also there is a chat line function which enables you to write your question. The message can be made public to all participants or privately just to me, whichever you prefer. So the session today, we're dividing into three parts. The first one is going to look at environmental legislation, and this has been a hot topic obviously over the last few years, and the drivers in many of the changes in container production. And in the opening session, we're going to discuss legislation, the implications, and predict a further tightening of emission controls. We'll also be reviewing some of the new technologies, and these new technologies were highlighted in the COA coatings report. And we'll discuss how these technologies are progressing in terms of being introduced into production process and what hurdles are being faced. And part three, we're going to be talking about reefer containers. And this is, of course, a very topical issue. And I know many of you have got specific interest in this, and we're going to make sure you have plenty of time to raise your questions, raise your points about this. And I'll say this now, if we feel that this needs a further webinar in the future, then we're more than happy to organize one specifically on that. But let's get it started today and see how we develop. So as I mentioned, the format today is a panel discussion. I'd like to introduce our panelists who are here to answer your questions. Delighted to welcome from KCC China, Wang Cheng, who's the Marketing Manager, KCC China. He's head of the Shanghai Sales Office and the TSD team leader. And we also have Cho Sung-Wung, who's Marine and Heavy Duty Coating Teams leader for KCC and in charge of the waterborne coatings R&D. KCC produces diverse products. You can see a bit of information about the company there. And by the way, this presentation will be available. So you've got some information about KCC, and we'll have some other information about the other panelists too. Also very pleased to welcome Kim Scheibel, who most of you know. Kim is Group Segment Director for Containers for Hempel. He's been based in Shanghai, China since 2017. And obviously he's got a huge amount of experience in the industry, 40 years with Hempel, got all sorts of high-level positions in the company, and he still looks younger than most of us. So again, very pleased to welcome Kim to the panel. Also, we have Tom McAfee from PPG. He's Global Segment Manager for the Trailer and Intermodal divisions of PPG. He's also been involved in the industry for a long time, 39 years it says here. So again, he looks remarkably well for the amount of time he's spent in this industry. And a bit of information about PPG there. And again, you'll have the slides. You can look at that more closely later. And also, finally, we have Zorro Pan, who's Coating Technical Manager with CIMC Containers. Zorro, again, has huge experience in this industry, and you really all know about CIMC, but there's a bit of information just in case you don't. So the way we're going to run this is we're going to have a series of questions from myself, and I'm going to ask the panelists to respond to them. And again, please feel free to ask questions during the course of the webinar as we go through it. If you've got any points you'd like to raise. We're going to start off with the environmental legislation section, and as I mentioned, it's been a hot topic. It's an important issue, and I really want some clarification from the panelists about where we're at with the implication, where we are at with the legislation, and what the implications are. So I'm going to ask the speakers from KCC to give us a brief update and summarize the environmental policies that are in place, and to put this into scale, approximately how many tons of VAC were being released prior to legislation and how that compares with it now. So, gentleman from KCC, can you answer me that question, please? If you can give me an update on the environmental policies that are now in place.
Okay, sir. Okay. Hello, everyone. Here is Wang Cheng from KCC Shanghai office. It's my pleasure to have this opportunity to attend this webinar together with you. And at this moment, I'd like to explain the environmental regulations in China briefly and share all the information we achieved right now together with you about the environmental protection policies in China mainland. First, about the regulations of the VOC emission. Oh, sorry, Patrick, here is the second slide. How about we just roll up to the first slide, okay? About the VOC content of the waterborne coatings on the new building containers. Then Chinese government encouraged using the eco-friendly products like waterborne paint. This slide shows the current VOC limitations in container coating, especially for the waterbornes. Actually now, there are no other eco-friendly products category in container coating market except the waterborne. There are some potential alternatives, but still need further trial tests to verify them. Other industries like industrial coatings, marine coatings, and automotive coatings, and so on, also have the high solid category, but still very high VOC content. Actually, in the container industry, until now, waterborne paint is the most effective countermeasure to reduce the VOC content of the material itself. Please refer to this table. The measurement method is getting more severe than before. Conventionally, when we measure the VOC content of the paint, we include water method, GBT 23986 10.3 or 23985 8.3 method. But now we have to use the less water method. That means we have to choose the measure method as the GBT 23985 8.4 or 23986 10.4. These measures can emphasize the VOC itself in the paint materials. And also, except these three China national regulations about the VOC content in the waterborne paint, the CCIA, China Container Industry Association, also have their own self-disciplinary restrictions for the VOC content of the container coatings. And their keep on reinforcement is still in the progress. And we believe it will be done very soon for the new standard, which should be the highest level of the limitations. Okay, how about the next slide? Patrick, please. Yes, thank you. This page shows us about the restrictions about the VOC emission. This is for the regulating the emission of the gas from the coating facilities. To meet the limitation, it should be considered the reinforcement of the environmental facilities as well as eco-friendly materials. At present, almost all factories have been installed the online monitoring equipment for the VOC discharging data inspection round the clock. However, the reading data exceeds the standard, the factory will be forced to suspend their production for the improvement. That's why right now many factories have installed their own dispersion system inside of the pending booth to avoid the direct discharge. This system, the working frequency usually is about twice or 3 times a week to keep a satisfied emission data. This slide also shows the emission limitation of each regional provinces in China mainland. We can see that each local province have its own concerned VOC substances and their own limitation standard for that. And also our industry are strictly regulated. The container factories and the paint makers, we keep on working closely to pay much more attention to meet the criteria of each located government. Okay.
Okay, thank you very much indeed. That's been very useful.
Thank you.
Kim from Hempel, can I ask you just to summarize what the environmental changes have meant to the coating industry as far as the investment to provide waterborne coatings and technical support, what level of investment this is required, and how a little bit about the changes there?
Yeah, thank you, Patrick. Sure. I can certainly say, first of all, in relation to investments, it has overall meant that we today have many more coating suppliers fighting for the same size of production, which we've had for the last 10 years or so. So the low margins we were accepting in the past have even shrunk further to a level which for the dry cargo containers have made some of us abandon the scene for a while at least. Yeah. So from the dry cargo manufacturing point of view, I fully understand what happened. Yeah. We, and I mean here, speaking on behalf of all the coating suppliers, we were initially able to copy the 3-coat solvent-borne system, which, as you know, consists of a zinc-rich epoxy acrylic top coat with an equal or better performing waterborne solution, even matching the production speed of the solvent-borne system without making any changes to the line setting. But the many new competitors saw their chance to enter this niche coating market. And you may laugh a little bit when I say niche coating market, because for us coating suppliers, at least for some of us, it is a small niche, but still important. Yeah? But some of these, they did not fully understand the application conditions. So the factories were asked to invest in more and better ventilation and heating systems, which today probably performs to an acceptable level for the owners, which are accepting the choice of the factories, who understandably is looking for the lowest cost product. And therefore, with the current one-shift production only and the general lack of containers in the market, the factories do not have time and test any new product or ideas. They simply need to produce the highest possible output they can. So from Hempel's side, then I might say that we no longer are able to compete on price, but I still dare to state that we today have not received a single performance complaint from any owner, be it from our first, second, or third generations, which were launched over the last 30 years or so. Yeah. So let me finish by stating that the waterborne application conditions need to be respected. There is only very little room for compromises, which mean temperature and ventilation conditions throughout the container production process need to be controlled and respected.
Very good. Thank you very much. That's very useful. If that's okay, we'll move on because we've got a lot of things to go through, but that's a very good summary and much appreciated. Tom from PPG, how do the environmental policies in China compare with USA and Europe? If you can perhaps give us a global picture.
I'll take myself off mute. Kim probably knows a little just as experience in Europe, excuse me, better than me. But in the US, we do target some industries. I would say that the self-imposed, we do everything in pounds per gallon for VOC in the US. So when you convert grams per liter, you're looking at the self-imposed restrictions for the container industry would be, Kim, correct me if I'm wrong, but that's less than 1 pound per gallon. The typical laws in the United States, generally throughout most of the US from a geography standpoint, are around 3.5 pounds per gallon for standard liquid spray coatings. There are restrictions based on what we call non-attainment areas in the United States, just so you all, just as a kind of comparison to what's going on in China right now, which are somewhere around 2.0 to 2.8 VOC, depending on the area. So similar to what the China government has done with restrictions specific to geographic areas. We have done that in the United States quite a long time ago. Again, it was a 1989 Clean Air Act that kind of drove all of this. But again, just briefly, it's been restricted based on geography.
Okay.
Not really targeting specific industries unless they are putting out an incredible amount, which is essentially what's been done here in the container industry. So that's kind of the comparison.
Great, that's very useful. Thank you.
And
Sorry,
Tom, can I add to this? When you say, well, how does it compare to US and Europe? I think the easiest comparison is that US and China is following the same way of calculating VOCs. That's excluding water. Whereas in Europe, we do include the water when we calculate the VOC. That's the biggest difference between the two. And then there are, of course, small variations in the numbers, but it's really that you have to either contain the water or abandon the water when you do the calculation. That's the biggest.
Which is more restrictive, point being.
It depends on the number, but it's just so you cannot compare across regions. If you look at one number, you need to know where it's originated and who have calculated it under what conditions. That's all I'm saying. They can be more restrictive depending on the area.
Yes.
No, but that's a useful differentiation. Thank you very much for clarifying that, Kim and Tom. And moving us over to the manufacturing side, the impact on the manufacturing side, I'd like to ask Zoro Pan from CIMC, can you give us an indication of what effects policies have had on container production and plant investment from a manufacturer's point of view in terms of drying and water treatment, and whether these environmental changes have had a positive effect on the health and safety of the workers and influenced improvements to other parts of the production process?
Oh, yes. Hello, ladies and gentlemen. I'm Zoro Pan from CIMC. First, the government requires container factories to install online monitoring systems to control VOC emissions. And the VOC types of solvent paint and the waterborne paint are different. So our container factory has to newly invest tens of millions yuan RMB for VOC treatment, such as upgrading absorption equipment or catalytic treatment equipment and so on. And second, the wastewater treatment standards from each environmental protection department of the government are very strict. Most places in China do not allow container factories to discharge the treated wastewater. And due to the emulsifier failure in the waterborne paint, it's more difficult to treat the waterborne paint's wastewater. So each container factory has to newly invest millions of yuan RMB for water treatment, such as add more treatment tanks or pools and equipment like RO membrane and so on. For the safety and the health of workers, yes, it does. The use of waterborne paint is very beneficial to the health and the safety of the workers, such as the smell of the waterborne paint is much less than solvent-borne paint, and it has very little irritation to the skin and the eyes and so on. So that's my comment.
Okay, that's very useful. Thank you very much indeed. Good. Okay. Thank you, panelists, for that. And if there's any questions from any of the participants at this stage, we're going to have time at the end of the webinar for general questions and discussion. But if you've got anything specific on the regulations, we've got a chance to talk about that now. But if not, we'll move on to the second section, which is an update on the new technology. Now, obviously, we've been talking about waterborne coatings, but the COA work group reports, it highlighted a number of new eco-friendly technologies. And I'm not going to suggest that we're going to go through each of these ones in details, but it'd be useful just to see where we're standing with some of them. We've identified, apart from waterborne, we've identified high solids coatings, one coat systems, electrocoating, and powder systems. Gentlemen from KCC, just tell us a little bit about where you're at with the waterborne coatings. I've got the slide here, which is how much you've supplied over the last 3 or 4 years. Can you just give us a brief update on where you're at with the waterborne coatings?
Good day, ladies and gentlemen. I'm Joe from KCC.
If you can maybe talk a little bit closer to the microphone, please, so we can hear you.
Okay. Thank you. We paint suppliers that continuously pay much attention to eco-friendly technologies and successfully replace the solvent-borne to the waterborne coatings. Eventually, we can reduce a tremendous amount of VOC in our products with the good cooperation of container manufacturers, like this slide. However, we never stop the advancement, even though successful replacement to waterborne. Actually, following 3 categories are still going on. First, we keep researching the robust formulation design for existing waterborne products. We already launched our waterborne products in the market successfully. However, we continuously try to stabilize and advance our waterborne product for reliable performance and workability. And the second, we continuously try to expand the waterborne product lineup. Currently, container coating markets still use the solvent-borne paint in partial areas like decal paint and the prefabrication primer and some special containers, including the refill containers and so on. We will gradually expand the waterborne application with new eco products.
Very good. Thank you very much.
Course,
okay. We're a bit tight of time, so just if you conclude with that little bit on waterborne paints, that'd be great. Thank you.
Yes, okay. Of course, we are studying for the new technology too. In various industries also have their own most suitable eco products. We try to introduce the new technologies to the container coating market if it is feasible. We keep researching novel technologies for container coating with a long-term project. Okay, that's all.
Great, thank you very much indeed. That's very helpful. The other products, of course, high solids and one coat system. Kim, are you able to tell us a little bit about where we're at with high solids and one coat?
Sure. I would say the biggest challenge for the one coat solutions is that they are not ideal for the lines as they are equipped today, spraying in the 3-coat system. So they would need to have new equipment installed to handle such systems. So that's the biggest challenge. So it's very difficult to test these type of products at the current setup. So it can only be done manually, which doesn't give a full reflection of the benefits doing it this way here. But it does, of course, show that they perform in real life once we get them out at sea there. But I would say to introduce a one-coat technology in the current lines, it requires not a huge investment, but it does have its cost. Yeah? But the factories, they seem to be focusing on the current production speed and output rather than thinking deeply about the environment. Yeah? So do remember, I would say, that the waterborne coatings still contain a relatively high volume of solvent. But all waterborne coatings used today will also meet the new GBT rules as mentioned before. Yeah. So if we really want to clean up this industry, we should look for solvent-free solutions, which can today be applied down to around 100 microns, which is what this market requires. Yeah. Other industries have already embraced this technology, but like all good new things, they do not necessarily come cheap as the container market want. And therefore the question is to ask the owners and the leasing companies then, are you willing to invest up front for a more sustainable solution, which potentially with an improved performance as well? that would be my take on that.
Okay, some fairly fundamental questions there, but thank you. Tom, I know you're looking at the electrocoating system. Can you tell us where we're at with that?
Sure. Well, we're kind of in the same category as the one coat system in terms of success. We continue to supply swap bodies and intermodal chassis and other storage type containers. So the process we know works very well. It's really a matter of, and COVID, unfortunately for us this year, where we were kind of in full swing with our market capabilities, with COVID, we just haven't been able to travel and haven't moved very much further than we were this time last year, quite frankly. But we know the technology from a environmental standpoint, since that's kind of what we're talking about here, certainly is, to Kim's point, is much lower than the current technology that's being used in the industry, and again is something that incorporates the biggest difference is that this system, as you can see by the pictures, incorporates automation, and that's where the efficiencies come from. The ability to coat a container at a very high success rate, that is to completely coat the container with a very even film. That's what electrocoat and powder coating do for us. Again, we are, to Kim's point, with the one coat, we're pretty much, the focus seems to be on the current technology that's being used, and that's kind of where it's at right now. We have opened up other factories in the last year utilizing this technology in China for this market, but not for container. So we're still working, and we still expect to have success with this technology. And we'll see what happens in the next year. Hopefully we'll have the freedom to travel a little bit more.
Very good, thank you for that. Can I move on to the manufacturing viewpoint then? Zora, perhaps you could give us an indication. Do you think that, or have you found that the automation is improving efficiency while reducing labor and costs? What steps have you taken to use automation in the coating process? And what about the efficiency? Are you tracking the transfer technology, the efficiency of transfer technology? Do you have any average efficiency rates at your factories?
Oh yes, and also CMC also is do some research on powder coating, and we for the automation. First of all, the labor cost in China is continued going up. It's a fact, and it is more difficult than ever before for container factory to find enough workers to do the works. Automation is the only way to solve this problem. And in the short term, I think the automation increased the invest cost, but in the long term, it will reduce the labor and the cost. And CMC has invested many spraying robots on at the door and then the front end and the base coating process. It works, and we save a lot of workers, and the efficiency has improved indeed. And the reason is not only by the automation, because we also increase the workshop area and we refined the working process, so the efficiency has improved not only by automation. And right now in CMC container factory is maybe is more than 300 units, 40-foot container per shift. Yes.
Very good. Thank you very much indeed. I'm just looking, I've got a couple of questions coming through. How does the container industry compare with ships, rigs, and other? Okay, I'll come back to that one later in that case. Any specific questions on these new technologies at the moment? No. Okay, fine. Well, we'll move on to the next. I've got a question coming in, but I think I'll hold that for the end. That was just a photograph of some of the applications of electrocoating and powder systems. I think there's Gives you an example of some of the work that's been done there. So come now to part 3 of the webinar, and this is going to be looking more specifically at reefers. And although reefers, as it says here, were exempt from the first stage of environmental policies, legislation, regulations are now being introduced. We're now going to discuss developments with reefer container coatings. So I'm going to ask Kim Scheibel, please. Kim, could you just clarify the existing coating specification and the likely changes that are going to be implemented in the coming year?
Sure. I mean, for reefers, there are 2 main options currently used today for shipping in the shipping industries for the reefer containers carrying foodstuff. And that is on the core 10 frames, either a hot spray metallization or a zinc-rich epoxy paint. Those are the 2 options you are as used on the areas which can corrode. And then the MGSS panels, then there's applied a special epoxy primer over the MGSS panel and over the core 10 frame with an acrylic or polyurethane top coat. Doors are painted separately on a special line, and they are also made of MGSS. So that's again a special epoxy primer, and normally with a PU, because it's nice when the doors, they look nice before you stuff in the food stuff into the container for carriage there. The challenge for the coating suppliers is to the overcoating of the superior hot spray metallization, where the coating have a tendency sometimes to bubble, as the zinc contains a lot of air, which need to be released during the mid-coat application there. So that's a challenge for any technology going over the hot spray metallization, whether it's waterborne or it's high solids or whatever. So those are the 2 systems based on the primer on the frames, so to say. Yeah, that's the main difference.
Okay, fine, thank you. So just so I understand, what are the benefits of switching to waterborne in the reefer field, which obviously is what's being proposed and what's going to be the issue there? How does the technology for reefers compare with the dry freight?
You're asking me again?
Yeah, would you mind just yes, please, yes.
Yeah, but I mean, I guess speaking on behalf of Hempel, then we have already developed several potential waterborne alternatives with various combinations of epoxy, acrylics, and polyurethanes, which are ready for line trials. They have been tested and they have all passed the IICL testings. But no reefer factory is really ready for such online trials, as their production lines are relatively short, because the solvent-borne systems were very forgiving in terms of drying speed in the past. But for waterborne coatings, if we want to trial those, then we need longer lines and more ventilation and drying capacity. So it's a little bit difficult to test really online with the current systems. Okay, and so if waterbornes are introduced to the reefer production, then the challenge will further be that the temperature, again, as I mentioned before, need to be controlled from the very first point they are entering the factory until they are dry and out of the factory again. Yeah.
Right.
Yeah.
Okay, well, I know you've got some slides, which we're going to, if we've got time, we're going to show some of your slides later on about some of your other solutions.
Sure.
Can I ask the gentleman from KCC, maybe you can just give us an update then on the timing of the implementation of the changes for the reefer container coatings?
Yes, sir. This is a working timetable suggested by the CCIA China, and this is a working timetable for the waterborne coat switch on the new building reefers. According to the original plan, the initial plan, the switching time should be the very beginning, 1st January of next year. And now everything is postponed due to various kind of reasons, especially for the COVID year this year. Then, according to the latest information from the CCIA, they call for the collective actions with all of these major 6 reefer manufacturers and also major paint suppliers. They have a draft plan just to see almost all the major reefer plants are going to commence their painting line modification in the middle of next year. Usually it will take 1 or 2 months for the line modification, just depending to the individual situations. Then we just expect maybe from the second half of next year, maybe July or August, then we'll complete the transition to the new coating system on the rivers. Then I'm totally agree with Mr. Kim about the last subject. I think the modification for the river lines not only concern about the drying, but also they need concern about the cooling. When the bugs pass out from the drying booth, how to make the surface, the temperature getting down for the subsequent coating application is still a question, because now present line layout of each major river manufacturers, they don't have this kind of working stage enough for the cooling. Then I think how to solve this kind of problem is still a issue for everyone. And that's all from me.
Okay, thank you very much.
Thank you.
Does any of our other panelists, would they like to say something? Zorro, would you have to, would you be able to tell us something about what you're doing at CIMC?
Oh, yes. CMC do a lot of research on the waterborne paint on the rivers, and I agree to King and Mr. Wang. We do need have enough area for the modification, and the workshop area is a big challenge for the right now the river factories because so far as I know, our river factories the area is not enough. So we must do more research on the cooling time and the setting time, I think. And it's also, we must find some correct way to control the VOC from the river waterborne paint and to deal with the water treatment in our workshop. And I get somehow every river factory may take 3 to 4 months to build a new coating line, and it may cost more than 50 million yuan RMB to build the new line. That's all.
Okay, thank you. Does anyone, we have a lot of container shipping lines, leasing companies, paint companies also on the call. Does anyone else want to make a comment at this stage? Any questions?
Maybe Patrick, can I make a further comment to
Yes,
what Casey correctly said here, which I applaud and so on, yeah. But I would also maybe challenge a little bit the high heat which is needed for the drying of the waterborne coatings, which very often runs into the 80s and the 90s. And how would the bonding of the foam on the interior side of the insulation material, how will that be affected? Because it hasn't cured for very long. That has maybe taken place a few stations earlier. So what does happen in the production line there when you then start to heat up the whole container with a very thin skin to quite a high temperature to dry the very thin coating system there, and then you want to cool it down, then you want to heat it up again, then you want to cool it down again. I mean, what happens there? I'm not the expert in production, but so I'm asking either Zorro, Pan there, or some of the more clever engineers on the call here, if they know what may happen here. I don't know, but I'm just putting up the question.
Zorro, can you answer that?
Okay, Kim, I'm not catching you. What's your point of the interior? Is the process for the drying?
Yeah, but you know, you are using a foam, an insulating foam as insulation material, which has just been pushed in or squeezed in to the hollow space in the sidewalls and the roof and everywhere. Yeah. And that needs to cure. And of course, I know it goes very fast by expanding and so on, filling up the gap. But how well does it manage to bond to the surface in a very relatively short time before you start heating up the container for the drying of the paint on the outside of that same piece of plate? Does that make sense?
Okay. First of all, I'm not the expert of the coating formula, but in the process, in the application, I think the factory have enough. We think we have enough time for interior coating for the drying, because it do has two process for interior top coat for drying. The middle coat oven and the top coat oven, we have more or less 45 to 60 minutes for the interior surface for drying, and then we have a lot of flames in the oven to make the water from the interior top coat to get out from the film. Yes.
Sorry, let me stop you there for 1 second. I am not to the slightest second concerned about the drying. I'm sure you can get that right of the coating system. That yes. I'm not worried about. That just takes time, and you have all the time you need. But what happens on the interior, which nobody can check? Have you investigated here what the heat which you are applying to dry the paint, what effect does it have on the bonding of the insulation material on the inside?
Can I comment here?
Yes,
this is Lars Luca from Maersk Container Industries. We have done some studies on this, and when we look at the foam adhesion in relation to the age from foaming and then to the process of applying the paint, once you exit the post-heating area, the adhesion with the foam is on the level that is expected. So we do not see that we have a weak period from foaming and when we enter into the main paint area. So our experience says that we can expose the container to something between 60 to 80 degrees of ambient in the ovens in the curing condition without jeopardizing adhesion, no matter if it's on inside or outside foam adhesion. So I think as long as we can cooperate with the paint specialists, the paint suppliers, and we can incorporate sufficient time in the ovens to allow us not to exceed these maximum numbers, we will be safe. If we come close, then test will show if we have an issue or not. This will be part of the approval process and the run-in when we go towards waterborne alternatives.
Thank you for that, Lars. This obviously is an important subject. We've got another 20 minutes. Does anyone else have any questions? We can talk about this a little bit further. I know we have Mark on the line, Mark Bennett. I think you sent me an email earlier on. I've got one question.
Hi, Patrick. Yes,
sorry, just one specific question. I've got one question from Brandanowski, which is asking, what temperature does the adhesion begin to fail when drying? Can someone answer that question?
It's probably more about the moisture content, if there is any, and that's why you get back to Kim, correct me if I'm wrong, with waterborne in particular. You want a temperature controlled environment, and you want a process that doesn't change dramatically whether or not the outside temperature and humidity change. So that's probably the key, I would imagine, to the system performing consistently and giving you consistent adhesion as well.
No, my question before, Thomas, was not about the outside paint, because that I know everybody can cure. That's just a matter of time and ventilation. Yeah. So I think Lars was maybe he can answer that second question here about the temperature. Lars Lübke.
Yeah, I can do that. We know for sure that we start to get into a gray area from 80 degrees Celsius and going up. We do not. We have done some high temperature tests on the foam adhesion, and we see that we are safe. We do not lose adhesion even going beyond 100 degrees. But the thing is, we get into a deterioration phase that we do not want to trigger. That's why we set the 60 to 80 degrees as a limit.
Okay, thank you for that. I have a question from Mark Bennett, which perhaps I can pose on his behalf. The question really says that waterborne conversion requires major production line changes and energy requirements for drying, plus possible negative impact on insulation foam and panel integrity, which we've been discussing. It seems a one-coat system would involve much less changed production lines and much lower energy requirements, as no heating or drying is required. Could the panel comment on why they believe waterborne is the best solution for reefers? It's a fairly fundamental question there.
KCC.
Could the gentleman for KCC indicate? I know you've done some work on new products for waterborne coatings for reefer containers. So could you explain to us why you think that the waterborne coating system is better than, or the best solution for reefers?
Now, first of all, waterborne technology can reduce the VOC contents more than 90% than current solvent-borne system. That means the capacity of environmental equipment also can be reduced. And second, no need special spray equipment like a pleural feed, the spray machine with the temperature control unit, and relatively easy to adjust the spray parameters immediately, like viscosity and film thickness and so on. Additionally, the reefer painting lines drying time is, I think, long enough than conventional dry van container painting line. So the modification can be minimized than dry van container painting line. Basically, we have good references in solvent-borne area, the zinc, epoxy, and acrylic or urethane top coat, which was proved by the market for decades. We have designed the final coating film with similar chemicals as solvent-borne container coating system, but use water in our products. That's all. Yeah, that's all my opinion.
Okay, thank you. Mark, does that answer your question? I know you've got a supplementary question as well. But...
Yes, well, thank you for KCC's response. I think what I'm struggling with is that low VOCs can be achieved by a number of methods. Obviously, waterborne coatings is one, but of course there is an enormous amount of heat energy required to dry boxes, which is a negative environmental impact. And I would suggest that any environmental solution that is sought to improve the paint systems on reefer containers should take into account both the requirement to meet low VOCs and the requirement to reduce the CO2 production, which is very critical from an environmental perspective. I know that VOCs immediately impact the local region of a country where they are emitted, but you cannot ignore the enormous electrical power consumption required to dry the paint systems on dry containers. And it seems counterproductive to do that on reefer containers if there are other solutions available today which fulfill both goals. And I think that's something that I think needs further investigation.
Right, we agree with you, sir. There should be another alternative choices for the reefers. Right now, the existing choice and we think the most effective way, according to the working timetable, the best effective way is waterborne choice at this moment. If there is another alternative choice, okay, this is a technology, it's a science. We respect every kind of new technologies. Just like you said, there is so many ways to make the VOC low for the emission. And we can do in various kind of a way to protect our environmental circumstances. Then I think the way is not only the waterborne paint, but the most effective way at this moment for our industry is waterborne. That's our opinion. Thank you.
Okay.
I know there's been some concerns about the cosmetic issues related to use of waterborne coatings on reefers. Do you want to expand on that?
Can I just make a brief statement and a question on that subject, Patrick?
Okay, yeah.
And let me say that I've been working on the production of reefer containers since the mid-1980s. So that's for 35 years. Container paint systems they are used today are required by all the owners of containers to last the life of the box, whether that's dry containers or reefer containers. It is simply not economic to refurbish paint systems during the life of the asset. We've become used to that, and I think it's been very successful in both dry containers and reefer containers that the paint systems have lasted for the full life of the asset. Now, on reefers, there are two additional factors that are very important for the industry to consider. They are painted white to better reflect heat, and also because as they carry food and pharmaceuticals and other perishable products, a reefer coating system must retain a good cosmetic condition over the full life of the asset. And this is really because, you know, premium shippers do not want to see their products going into scruffy reefers, because they believe that perhaps the integrity of the machinery and the insulation is also compromised. Now, whether that's right or wrong from a technical viewpoint is not the issue. We cannot change the view of the cold chain and food distribution industry. That is their strong bias. So as we have successfully achieved production of steel reefers since the 1980s with good paint systems, and certainly they've been lasting the life of well-built reefers for 35 years. This is welded steel reefers. Can the panel comment and demonstrate to owners, the operators of containers and investors, that new coating systems for reefers will provide equivalent cosmetic performance over the full life of the container? And the full life, I should stress, is not 10 or 12 years, but this is 15 or more years. This is what the target for the life of a reefer container is today. So can the panel comment on how these new systems will achieve a good cosmetic performance over the full life of the asset?
Who would you like to address that to? All the panel?
I think anybody on the panel who can comment on that would be very welcome. Thank you.
I would like to answer some of them at least. I don't know, Patrick, if you have a few slides I sent to you earlier today.
Let me
maybe
yes.
Those, because we just learned from the CIMC that it cost them around 50 million renminbi to install a new paint line, and that's in euro terms around 6.3 million euros. But such a pump as you see in the picture here was used. That's what is known as a two-component pump, and that was used for application of polyurea technology. The polyurea technology, that's a relatively new technology coming out of Europe, which was patented for some years back, but now the patent has been lifted and everybody can go and venture into this. And so the cost has come down somewhat. Yeah. So we did a trial for 5 times 40 foot reefers there and applied 100 microns, as you can see here. And you can see the container in the background there. This is after 2 years in service. And do note that the doors here are painted with a traditional and current system, which is an epoxy primer. Go one back, please. If you can go one back, Patrick. So I see the one with the door, yeah. So if you just stop here for a second, the door panels here are painted with the traditional epoxy and polyurethane, and then you can see the polyurea after 2 years in service there. And now I'm seeing the one with the application again. I don't know what you guys are seeing. I would love to have stopped with the one where you see the box after 2 years.
Okay.
Can you do that? Is that possible?
This one? No.
This one.
Yeah.
Okay. But anyway, you see for yourself here. You can see the impact resistance and the scratch resistance of this kind of coating type. And do note that these frames here, the corner post and the bottom frames and top frame there, that's with hot spray zinc, and then the polyurea applied directly onto these, including also on the panels here, which is muffle grade stainless steel. And you can see there are indent damages, there are scratches, and there are even up around the top corner casting there. It doesn't look nice, but in my view, it actually maybe looks even better than what we've seen in the past from the solvent-borne systems. And this type of technology here has a similar VOC footprint as does the waterborne coatings. And here we do not need high temperature. We only need 30 degrees C, and then it will be dry to handle in 10 minutes, meaning very little ventilation, very little heat. So all of this heating up, cooling down, heating up, high ventilation is no longer required. So I would say there are definitely alternatives, but it does require a different set of pumps. But that's a relatively small investment, which probably would be in a range around, I would guess, around less than 200,000 euro compared to 6.3 million euro to switch to a waterborne layout. Here you're having a close-up of an indent of a damage, and you can see how flexible the coating is. So I would certainly say there are other technologies out there which is as doable and maybe even better for what Mark was just asking for, how do they last for 15 years? I dare to say that this one will be looking nice after 15 years, maybe because the paint will even hold up longer than that. But that's just my say.
Okay, so that's one possible solution then.
Yeah.
Do any of the other panels want to respond to this question about the appearance? No, not at the moment, but clearly this is something we're going to have to look at.
Patrick,
Yeah.
This is John Williams here from Triton.
John, hello.
Yeah, Kim, the pictures that you're showing, those that's your one coat system put over hot zinc spray. Is that correct?
That is absolutely correct. Yes.
Yeah. So one of the issues that we're facing right now is the possible elimination of hot zinc spray. How does your system, did you test your system with no hot zinc spray?
Oh yeah, you can apply the same system over zinc primer, but I'm very much fan of the hot spray zinc because I think it offers, as you can see here, a fantastic anti-corrosion performance there. So I have no problems continuing with the hot spray, which I think is a great solution. I would not mind to sell some zinc coatings as well, but I can certainly accept and applaud what the hot spray zinc does for the container life there. So I'm happy to continue as is. I don't see the problem because hot spray metallization is used in so many industries with great success. So why do we have to abandon a great product solution in the container industry? I don't get it. I think we are looking at a different agenda here. Because I think, as Mark was saying before, we need to have the long lifetime, and then we need to look for the best.
Yes, I agree.
Okay, we have a couple more questions coming in. I've got one from Nigel Webster from Beacon. Can the paint suppliers advise or update on any solutions being worked on to maintain hot zinc metallizing on court end parts, but for use with waterborne paints on reefers? So
I'd like to know if Lars has done any comparisons between, maybe Kim, you have done it as well. Certainly when you apply spray metal, when you metallize, you're essentially putting down pure zinc. So everybody knows what hot dip galvanizing does, for example. But I'd be interested to see what the comparison is. I mean, there's no doubt when you put zinc in to an inert matrix like an epoxy, you're not going to get the same performance. And I'm assuming, and PPG has not done specifically that comparison, and Lars may have done it, and or Kim, maybe you all have done it. The comparison obviously between a zinc containing epoxy versus metallizing, and where's the drop off if you do salt spray or cyclic corrosion testing or something like that? Can you project the performance then between the two, doing that benchmark testing?
But Thomas, that's a different question from what I understood was being asked before.
Yes, yeah.
I think the question was, how do you repair them? And no, there is no comparison in repair systems. We cannot get up to the same anti-corrosion level in repair coatings. And so you have to deal with what is possible at a depot situation or out in the container yard. How can you repair? And the best way to repair would, in my view, be to use what is known as a one-component zinc-rich epoxy, which it doesn't need to be mixed, because as soon as you start mixing, then people forget the shelf life or the pot life of the coating there. So you need to find something which is single component, which can be used by anyone around the world, whatever language they speak and how qualified they are. And those coatings are available and in stock around the world from certain companies. We have had this product on the shelf for many, many years. And if we want to use a zinc, that would be my best suggestion, because going in with a 2K epoxy zinc, it would just give us further complications and difficulties, and you would not get the performance. And so, Thomas, your question is very different.
Yeah, but there are two questions. We have one from Benjamin Brico, which is asking about this question of maintenance. Waterborne paint requires very stringent and controlled ambients, which are not compatible with repair depots all around the world. So was that addressed when choosing waterborne? So that was one question. And then we have the question about working on solutions for maintaining hot zinc metallizing on court end parts, but not for use with waterborne paints on reefers. So there are two questions, one on the maintenance side and one on court end parts.
Yeah, if I can go on again, for maintenance, then I fully agree and understand the concern there, because there is no easy answer here. It very much depends on local legislation from country to country and the temperature and environment you're operating in. But do remember, if you do a waterborne repair, for instance, on an interior of a container without any ventilation, it's going to fail within an hour, because then you're going to have flash frost. So I would certainly recommend, again, to go to the only way to get rid of solvents, if there's a solvent concern in the country of application, would be to go to high solid epoxies on the interior, and then to go with something which is legal on the outside. I'm not so concerned about the ventilation on the outside if it's small damages, but there need to be ventilation. Otherwise, waterborne coatings on steel in a depot situation will also create flash frost. So they need to be ideal condition above, preferably 10 degrees C, which is not always achievable. So therefore, probably winter cured epoxies in cold climates is the right way to go. So it need to know a bit more about which part of the world are we talking about repairs, because of temperature.
Yeah, this is obviously going to be a problem there. Did we answer the second question from Nigel Webster? I don't know if you can see it on the screen, but solutions being worked on to maintain hot zinc metallizing on coating parts, but for use with waterborne paints and reefers.
Yeah, but as I was saying before, there are one coat zinc-rich primers available for repairs. They are not as good as the hot spray metallization. They are not as good as a two-component zinc-rich epoxy, but they are probably the best what a depot can handle, without talking down to them that they don't do quality and so on. But it's simply they don't have the means, and they don't have the workstations for it. So this is probably the best version, with a one coat, with a one component zinc, and then overcoating it with top coats to give it the right color.
Okay, thank you.
If I can put a comment on,
Yes,
on the second question. So the thing is, if we try to assess the long-term performance when going to likely a waterborne alternative, low VOC product, and what will happen if we take away hot zinc metallizing, I think if we look into the historical experience we have given the solvent bonds when we do exactly the same exercise, and then try to put that perspective on top of what happens between solvent bond and waterborne systems. On the solvent bond side, we have historically from time to time been running with or without hot zinc metallizing, enabling us to look at containers that are 5 years old, 10 years old, 15 years old, that have a fairly good overview of how the performance difference increases as the container ages, and also a key argument why we from MCI side feel strongly about the motivation to keep hot zinc metallizing if we want to justify the long-term performance of the assets. So when going from solvent-borne to waterborne, and when we do the laboratory approval tests and the initial test without the historical aspect, we can see there are some things in general from lab side. Waterborne systems are on par with solvent-borne systems, but the application window is often it's more tricky to apply, as also mentioned here earlier in this session. And the consequence, if not applied correct, is that we will see more defects. And if we don't have the secondary protection system that the hot zinc metallizing is offering, then those defects will be apparent, which they are not, because the solvent bond today are more forgiving. So I think there's an honest risk that we are not able to deliver the long-term performance of a reefer container that our customers are expecting of us. So from our side, we are cooperating with all the paint suppliers, and the feeling I get from per manufacturing side is that we get very good cooperation from the different paint suppliers, and this cooperation and the results that we gain jointly is comforting me towards that we will be able to keep hot zinc metallizing, and we will be able to meet the requirements, the environmental requirements. We don't need to compromise on this.
Lars, this is Lars, isn't it? Lars speaking. I'm obviously not an expert on this, but I do understand that you have an automated system. Can you tell us a little bit more about that? Automated system you've got.
we will be getting. We are in the same situation as any other container manufacturers, that we are in a transition phase between solvent-borne forgiving systems and the new and meeting the new requirements from any kind of alternative product. The approach we have is not only to ensure that our product, our modified paint line is able to apply a hot zinc metallizing, and also consider any kind of striping system that might be needed in order to bridge the gap between the metallizing and then applying a waterborne alternative. But we are also very seriously investing efforts in looking into being able to apply one-coat alternatives. We don't think a decision has been made yet on what will be the final low VOC product. I think this is still a lot up in the air, because requirements for reefers are different than dry. So there's only so much you can take of learned lessons from dry container and move into the reefer segment. So that means we are building in flexibility to the extent that we can afford and that we feel makes sense.
Thank you. Mark, I think you have a comment on this.
Yeah, sorry, just unmuting myself. Okay, I just wanted to really add to this. Really, the concern I think of the industry is about the zinc metallizing. And as I say, my former employer, were using zinc metallizing from 35 years ago with a very successful process. And as we know, it's widely used in global industries, including the offshore windmill industry, for example. China's a world leader in this. I'm sure they're using this product extensively. So I think from a usage point of view and safety issues and environmental issues, there are absolutely ways of applying it in a safe and environmentally friendly way. But from experience of using refrigerated containers with or without zinc metallizing on the corten frame, we've seen examples of boxes with solvent-borne paints, of course, with using zinc-rich primer on the rail system that after 5, 6, or 7 years are showing significant rust corrosion markings on the paint system. Simply because on a dry container, if this happens, you don't notice it, because a lot of the dry containers produced are colored, maybe brown or other colors that the shipping lines use, where the corrosion just doesn't show up. So I think the industry must accept that if we were forced, for example, not to use zinc metallizing, that we would see the life of the container asset significantly decreased, either requiring a full refurbishment of the container, perhaps after 7 or 8 years, if cosmetic performance is required in the future, or early retirement of the containers. And from an investor's perspective, this is simply not a viable prospect at all. So I think that every effort needs to be made by the container manufacturers to find safe and efficient ways and environmentally effective ways of using zinc metallizing. As I say, it has a 35-year track record in this industry, very effective on steel reefer containers. And I think it's essential that the industry continues to use this in the future.
Good. Thank you very much indeed. Clearly, there are lots of questions and not all of them have been answered properly, but very much appreciate the discussion we've had. And I'm going to suggest that probably we'll have another webinar specifically looking at this issue of reefer containers and coatings in January of next year. The original idea of this webinar was to look at the work that the COA work group had done on the container coatings report, which is available on the website. And obviously it's evolved a little bit since then. Just before concluding, I'm going to hand over actually to the chairman of the Container Owners Association, Uwe Fredriksson from Maersk, who just would like to say a couple of words before we finish today's webinar. Uwe, can I hand over to you for a moment?
Thank you very much, Patrick. And I always learn something from the paint conferences, and thank you all for that. I find it highly enlightening to learn about what's going on in the industry, and I find it really thrilling to see that you all display this dedication to something that is so paramount for the entire industry. Before I go in a little further, I'd also say it was a very well conducted meeting, and I think this is one of the most effective webinars I've been participating in. And of course, it's very good to see that we are all getting used to meeting visually. It's challenging that we cannot see each other and shake hands and so on and so forth, and of course, the corona has been beaten like a dead horse for many months now, but still it remains a challenge for us, and it will also remain a challenge going into 21 and probably into 22. So I think it's great that we are learning to adapt to the situation and get the most of it, and that we can keep up the business that we like and enjoy so much. I think it was a very good participation and very good engagement. And as Patrick said, we will be doing regular webinars in the new year as well. And I'm also delighted that it seems that there's enough in this topic here of container coatings to have a follow-up in January, because I think that's important. I like that all the presentations had the environmental angle first and foremost, and I find paint as interesting as the container itself, right? Because if you can solve the conundrum of making the container last forever and not require so much maintenance, then you are a step closer to solving the longevity issue that we all look at. And if we can do that by applying environmentally friendly paints and solutions, then we are even closer. And of course, we all know that the environmental angle and the climate challenges that we are facing is something that we are all dealing with every day. I think all of the participants here are somehow involved in addressing the environmental and climate challenges that we have. And let's not either forget the safety aspects, which was also mentioned a couple of times. The industry has now, in the last couple of years, adapted an attitude towards safety of the employees that we work with and the machinery and the assets that we operate, that safety is paramount. We are beginning also to see safety spread across the alliances and the partners that we have. So I think it's also very nice to hear that this is also front and center in the presentations that we've had here. All the presentations were very, very relevant, and I would just like to thank each and one of you for all your support and engagement. And I look forward to seeing you again in webinars over the next year. Special thanks goes out to Patrick and Colin for putting this together. And I hope you all enjoyed it as much as I do. And I'd like to wish you all a happy festive season. And thank you for your support. Over to you, Patrick.
Well, thank you very much indeed, Uffe. Much appreciate your comments there. So just on behalf of all the participants, a final thank you to the speakers from KCC, Hempel, PPG and CIMC. Very much appreciate your preparation for this and for participating and answering the questions. As I mentioned, a copy of the presentation, we'll make that available later today. And I do actually have a recording of this in case anyone has missed it. So finally, as mentioned at the beginning, this is the second of our series of webinars. We'll be announcing details of the next ones as soon as possible. If you're not receiving emails from me properly, please let me know. I know some of you have had trouble. We have firewalls and all sorts of other things to avoid any cyber attacks into companies. So apologies if you've had any trouble in receiving emails from me. We do make announcements, and generally speaking, we put stuff on the website, but we'll try and make sure that we find ways of getting the communications better. So once again, thank you for those, particularly those who've got up in the middle of the night to listen to this. Hopefully you can get back to bed now, and those who've woken up early, please do have a good day. Very much appreciate your time today, and thank you again. Bye-bye for now.
Thank you, Patrick. Thank you, everyone.
Thank you, Patrick.
Thanks then. Bye-bye.
Thank you, everybody. Thanks, Patrick.
Bye.
Thank you. Bye.